with academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So right here, we have 2 to the power of x plus 1 to the power of 2 equals 64. And what we're first going to do is we're going to simplify this term a little bit. So whenever we have, let's say, a to the power of b to the power of c, this is also equal to a to the power of b times c. So these two exponents simply multiply. So for this term, we have 2 to the power of x plus 1 to the power of 2, meaning that these two terms are going to multiply. So this leaves us with 2 to the power of x plus 1 times 2. Remember, the exponents are simply multiplying. And now this is a distribution problem because this term 2 is multiplying with two terms that are adding up with each other. We want to distribute this to all the terms in the parentheses. So if we multiply 2 by x and 2 by 1, we get 2x, because 2 times x is 2x, plus 2 times 1 is simply 2. So this leaves us with 2 to the power of 2x plus 2. And this equals 64 still, right? So now what we want to do is we want to change 64 so that it has the base of 2. Because remember, if we have two numbers, let's say a to the power of x and a to the power of y. If their bases are the same, then doesn't that mean their exponents are the same too? Yes, because if their bases are the same, so can their exponents. If their exponents are different, then that means these two are two different values, and that wouldn't work out. So if we make both of these bases the same, then we can simply make the exponents equal each other. So 64 is actually equal to 2 to the power of 6. 64 is 2 to the power of 6. So now, as you can see, we have a base of 2. And this still equals 2 to the power of 2x plus 2. And remember how I said before, if these two bases are the same, then that means the exponents here, these two are the same as well, meaning that 2x plus 2 is equal to 6. So now we could just ignore these bases and make our equation right here. 2x plus 2 equals 6, and we're solving for x. That's what we wanted to do all along. So we're going to first subtract 2 on both sides to isolate x. So we have 2x equals 6 minus 2 is 4. And now we're going to divide by 2 on both sides. And let me write this right here. We have x equals 4 divided by 2 is 2. So x equals 2. And that is our answer. And now why don't we plug this into our equation here and see if it's right. So we have 2 to the power of 2. Remember, we're replacing 2 with x plus 1 whole squared equals 64. 2 plus 1 is 3, so we have 2 to the power of 3 whole squared equals 64. And 2 to the power of 3 is 8, so we have 8 squared equals 64. And what is 8 squared? 64. So 64 does in fact equal 64, meaning x equals 2. And this is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out. So we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0 equals 1. And remember, anything to the power of 0 equals 1. So 10 to the power of 0 equals 1. So we have 1 equals 1. And this is right, meaning our answer of x equals 3 is right.